Welcome to Planet Earth, where we embark on a journey to uncover the intricate workings of our planet's remarkable life support system. As we delve into the global climate, we aim to understand the factors that make Earth so hospitable to life while exploring the catastrophic fate of our sister planet, Venus. Join us as we venture into the winds, the oceans, and the forces of nature that shape this dynamic and awe-inspiring planet. Imagine Earth as a complex machine, powered by the sun and equipped with its own set of cogs and motors. However, unlike a machine that comes with an owner's manual, our planet's inner workings have fascinated scientists for centuries. They have launched satellites to unravel the secrets strewn across Earth's atmosphere, oceans, continents, and even beyond the solar system. The birth of our planet's components can be traced back to the distant supernova explosions that scattered heavy elements like iron, calcium, and potassium throughout the Milky Way. These elements, the building blocks of life, eventually formed the basis of Earth and everything on it. Yet, supernovas also unleashed high-energy particles that could have been lethal. Fortunately, our star, the Sun, acts as a protective shield for our solar system, creating a force field that deflects these cosmic rays. However, solar winds, particularly during coronal mass ejections, can pose their own dangers, as evident from the fate of Venus. Solar storms strip away lighter elements in Venus' upper atmosphere, including hydrogen and oxygen, the components of water. What remains is a toxic concoction of chemicals, including thick sulfurous clouds. At its surface, Venus is enveloped in a dense atmosphere with extremely high concentrations of carbon dioxide, a potent greenhouse gas that traps the sun's heat. As a result, Venus has become a searing cauldron, boasting surface temperatures of nearly 500 degrees Celsius, making it the hottest planet in our solar system. In contrast to Venus, Earth has managed to avoid a similar grim fate. Our planet's protective shield lies in its powerful magnetic field, generated deep within its core. But that's only the first line of defense. Much of the solar energy that manages to penetrate Earth's defenses is reflected back into space by clouds, ice, and snow. The energy Earth absorbs is just enough to power a remarkable planetary engine, the climate. Earth's climate engine is set in motion by the unevenness of solar heating caused by the cycles of day and night and the changing seasons. These variations drive warm tropical winds toward the poles and cold polar air toward the equator. Wind currents, in turn, influence surface ocean currents, such as the Gulf Stream, which carries enough heat energy to power the industrial world 100 times over. This massive ocean river redistributes warm tropical waters over northern seas through intricate patterns and whirlpools. The climate engine comprises countless moving parts, from tides and terrain to crosswinds and currents, all working together to regulate temperatures across the globe. However, when tropical heat reaches extreme levels, it can be unleashed in the form of intense storms. Hurricane Katrina, a monstrous storm that wreaked havoc in 2005, serves as a prime example. Computer simulations of hurricanes, like Katrina, allow scientists to better comprehend the dynamics of these powerful weather systems. The winds and evaporation of warm seawater fuel the storm's intensity, drawing heat energy from the ocean and causing the winds to accelerate. The power of hurricanes, capable of releasing enormous amounts of heat energy, demonstrates the intricate interplay between storms and Earth's climate. While storms release heat stored in the ocean, they also stir moisture into the atmosphere, which aids in keeping the planet warm. Water vapor, along with carbon dioxide, acts as a greenhouse gas, trapping solar energy. However, Earth has managed to keep carbon dioxide in check, unlike Venus. The secret lies in life itself, particularly in the oceans teeming with microscopic organisms called phytoplankton. These tiny beings, invisible to the naked eye, absorb carbon dioxide from the air and release oxygen. Carbon then journeys up the food chain, starting with phytoplankton being consumed by zooplankton, which are then eaten by small fish, and so on. At each step, carbon accumulates in larger animals, eventually finding its way back into the atmosphere through respiration or decomposition. This carbon cycle, facilitated by Earth's ability to store carbon long-term, plays a crucial role in maintaining a habitable environment. Plants on land also contribute by absorbing carbon dioxide through photosynthesis and depositing it in the ground when they decay. Exposed rocks absorb carbon dioxide through chemical weathering, which can be carried into the oceans by rainwater. From there, carbon-rich matter can sink to the sea bottom, forming sediments that can become oil or limestone over time. Through volcanic activity and plate tectonics, carbon dioxide can be released back into the environment or pushed deep underground. Earth's ability to regulate its carbon cycle is fundamental to its habitability. However, with the rise of human activities, the balance has shifted. The amount of carbon dioxide released into the atmosphere from burning fossil fuels, such as oil and coal, now surpasses that emitted by volcanoes by over 200 times. As a result, the concentration of carbon dioxide in the atmosphere has increased by nearly 40% since the Industrial Revolution, leading to a rise in global temperatures. The consequences are already visible, with melting ice caps, rising sea levels, and shifts in weather patterns. As our understanding of Earth's climate systems grows, we have come to realize the importance of preserving and protecting our planet. Our impact on the climate, as observed from space, has prompted us to ask a crucial question: should our goal be to exploit or safeguard Earth? As we continue to explore the intricacies of our wondrous planet, it becomes increasingly evident that we hold the key to Earth's future. By embracing sustainable practices and working together, we can ensure a harmonious coexistence with this extraordinary planet we call home. In conclusion, the dynamic nature of Earth, from its protective shield against cosmic forces to the intricate climate engine driven by winds and oceans, highlights its remarkable ability to foster life. Earth's success in maintaining a habitable environment lies in the delicate balance of the carbon cycle, with life playing a vital role in absorbing and releasing carbon dioxide. However, human activities have disrupted this balance, leading to rising carbon dioxide levels and significant climate changes. As we gain a deeper understanding of Earth's interconnected systems, it becomes crucial to prioritize the preservation and conservation of our planet, working together to secure a sustainable future for generations to come.